So last class we reviewed some of the attributes types, and if you remember some of the attributes types such as nominal, binary, ordinal, interval type, ratio type, discrete attribute type, and continuous attribute type. So we have already reviewed all those attributes. So let me just give you a quick review about the concepts that we covered last class, because today the concepts that we are going to cover, they are mostly related to all these attribute types. So as you know, the different data sets are nothing but the collection of objects, and each data object is nothing but an entity, and the characteristics of data objects are called as attribute types or attributes. So there are different types of attributes. So one of them is nominal type. So nominal type, so these are nothing but the symbols or name of certain things. Sometimes the nominal attributes are also can become as categorical attribute, or they can also follow certain type of meaningful order. We have binary, which mostly can have two set of states. It may be either 0 or 1. 0 means off, 1 means on. So binary attributes are again it has again two subdivisions, that is symmetric, asymmetric. So if the two states that the binary attribute have, um, if both of the two states are equally valuable, that means same weightage, then they can be called as symmetric. If they don't have the equivalent or equally important states, then it is asymmetric. So here the gender, the male or female, can be symmetric binary because both of them have equal importance. But let's say medical test, it can be positive or negative. So you proceed accordingly. So it's if it's a positive medical test, something you need to be worried about, then you go under certain medication. So this is the basic classification of binary attribute. Then comes your ordinal. So ordinal, it's this type of attributes, they have mostly some meaningful order, and some of the examples are given here. Then comes interval. So intervals are they are measured on a scale of equal sized units. So the value of interval scaled attributes, they can have order. They can be positive, 0, or negative. Basically measured on the scale of equally sized units. Some of the examples are given also. Then the ratio, and there are two major difference I need to mention: interval and ratio. So interval doesn't have a 0 point. So okay, so you don't actually consider a 0 point. So if you have a centigrade Fahrenheit, so in the temperature or the calendar dates, you basically don't emphasize on a 0 point. But here in the ratio scaled attributes, so here this is it has all the properties of interval attribute. So whatever properties the interval attribute it has here, the ratio also have the same, but it has a inherent 0 point. That means a clear definition of 0 point. Then comes our discrete and continuous attribute. So discrete attributes, these are just a finite or countably infinite set of values, and which may or may not be represented as an integer. Okay, and continuous attributes, these are mostly real valued attributes, and these are not restricted to define separate values, but can occupy any value within a continuous range. So some of the classification of these attributes, which are important, that you should learn. Next, moving over to basic statistical description of data. Next part in this chapter. There are mostly 4 areas are to be covered that you see here: motivation, data dispersion, numerical dimension, and dispersion analysis. So actually data understandability is really essential for statistical description of data. That is why we are going to learn about it. Because doing any sort of analysis, you mostly have to um, uh, particularly understand the data, so that once you understand the distribution of data, or how the data is behaving or have been distributed over, then you will be able to choose a model to analyze it properly. That's why the data understandability is most important. So there are some of the central tendencies, some of the formulas you may have heard about it: finding a mean of certain values, median of values, or mode of values. So the mean, it's the algebraic measure, and here um, the arithmetic mean is to be calculated in this way. So let's say you have n number of variables, and you want to or values, you want to find out the mean of those. Then you can just add all the values together divided by total number of values. That is mostly your mean. It's just easy, you always use it. Then comes your median. So it's just for middle or the median value of a set of odd numbered values. And these are the some formulas which are used for this all set of operations. If you want to get more details about it, there are also examples could be found inside the book as well. You can also refer them. Here I have included one mean calculation example. So if you see, mm, here the salary values in the unit of dollars, thousands of dollars, it is mentioned in this way. This is the book example. You can also refer it in the book as well. So within these values, how to find out the mean? Actually, you just have to add all the salary components or the values available divided by total number of values. If you count them, it will be 12. So the here it's 58. So you are just converting the 58 to the units of thousands of dollars. So 58,000. Then there are certain cases in which you may want to associate some sort of weightage to the individual values to make some sort of tuning to your data set. So in that case, this will be the formula, and this is how it will be computed. Actually, why we are incorporating this weight here? Because in case if you have heard about some machine learning models for analyzing data, then there is a neural network. So in that case, there are different layers, and in some of the layers, uh, you all you I mean using already the original data set, you may also want to add or consider some sort of weight or additional weight to the original data. So in that case, you can the weight comes into picture. Then symmetric versus skewed data. So what is this? So if you refer to the previous example, that is this here, then we can see that the mid range of the data will be the first value plus the last value divided by 2, which will come around something like 70. So first let's say you find out the median. So there are different pictures here available to you: symmetric, positively skewed, negatively skewed. So what are these? So this type of curve is actually called the unimodal frequency curve. Okay, and sometimes it has symmetric data distribution, in which in the symmetric data distribution, if you see, the mean, median, mode are all at the same center value. Okay, um, and here this is the picture. And data in most of the real applications, they are not symmetric actually most of the times, and they may instead be either positively skewed, where the mode occurs at a value that is smaller than the median that you see here in this picture in figure B, or it can be negatively skewed, where the mode occurs at a value larger than the median. So these are different types of data distribution: symmetric, positively skewed, or negatively skewed. And while analyzing data, you may encounter this sort of data distribution, and all of the different type of data distribution, it does have different steps to follow for analyzing data. Then as we're learning about the data dispersion, okay, let me this picture, actually it's going outside. Let me If you could refer to the slide in your, okay, I made a mistake actually. The link that I have given in Blackboard, it is also the same thing. I will update another one slide with possibly the picture available to you. So let me just annotate it. So actually what happens, so if you have this type of data distribution, okay, so the median, this one is called your median. Okay, this is your whole data distributed in this manner. So the middle portion is your median, and it can be called the 50. You also can see the picture in the book as well. Okay, you will find the same picture in the book. So this is the 50%, that is the 50th percentile of the whole data distribution. If we take this much and this much here, okay, so this part is 25% and this part is 25%. That 50 is divided into two parts. So here this part here, this line can be called as 25 percentile, okay, or this is also called first quartile. And here this part, this section here, this point, this is called 75, oh sorry, 75 percentile, or is also called third quartile, okay. And here this one, this part is the most smallest, or the minimum, you can say. Let me change it, or the minimum point, okay, where the data distribution begins. And this part, it's the maximum or the largest. So this is how, if you want to understand the data, then you just have to find out which one is the median. Oh sorry, median. And then this part, these two are divided into two. So the first part is your, this part division is your 25th percentile, 25 percentile, or the first quartile. Middle one is the median range, which is the 50 percentile. 50% is a 50 percentile. Then next 25, it will be around 75%. And this area is called, whole area is called the third 75 percentile or third quartile. And the last one is your maximum. This is basically what is explained here. Okay. Then, in addition to that, the quartiles are defined. Then there is the interquartile range is to be defined in this format: third quartile minus the first quartile. And the third quartile is your 75 percentile of data distribution minus the 25th percentile of the data distribution in the figure that I was showing you. Then there are 5 number of summary, that is minimum, first quartile, median, third quartile, and maximum. It's mostly the similar thing that I was just showing you. Then box plot. So there is one type of data visualization which is also called box plot. I will show it to you later in another one slide. Then there is outlier. So outlier is something who it's a basic data in a set of data in a set of data or in a data set, where there are certain points, if they don't actually have similar characteristics to other points in the data set, then these are called as outlier. Then we can also find out the variance and standard deviation as well, and of the data set, and these are the formulas. This is how they are calculated. So standard deviation, S or sigma, it's actually the square root of the standard S square or the sigma square. And the variance is actually calculated in this way. So next, the box plot. So in the box plot, again the same thing: the minimum, first quartile, median, third quartile, and the maximum range. It's shown in this type of box format. So this is what it's explaining about. So let's say if you have a plot like this, in this first branch 1 data, so in this box, so here this one is the first starting the minimum point. So here is the first quartile, median, third quartile, then the maximum range. So this is, from this you can understand that the 25% of percentile or 25% of percentage of data is beginning at the unit price $60, and the maximum it is ranging up to somewhat below 160, 158 or 59 something. So from this you can learn how the data is actually distributed. So this type of plot is called your box plot. Okay, so the formula that I was showing you, the variance and standard deviation, there is an example which is from your book. I have added it here. So for the example, the last example that I was showing you, where you calculated from a set of salary values, you calculate the median value as 58,000. So using that median, how can you find out the variance or the standard deviation? So the sigma square will be all the individual values of the salaries, 12 values that you have, divided by your 12 total number of values minus the square of the median value. Okay, and this is how it is to be calculated. You also can find this example in book as well. Next, we saw box plot, quantile plot. We are going to see that, but it is mostly related to that quartile or quantile of values. So histogram, these are used to show distribution of variables, while bar charts are used to compare the variables. Okay, so from here in this histogram or bar chart, what you can understand from here, so at the value of somewhat around to 20,000, the distribution is highest from the maximum sized bar. From here you can learn that. And histograms actually always plot quantitative data with ranges of data grouped into bins in this type of bars or bins or intervals, while bar charts usually plot the categorical data. Then some more about your box plot and histogram. This is mostly theory. Then here you have another type of plot. So actually it is not often used, the quantile plot. We mostly do the histograms. There is another one, scatter plot, bar plot. They are mostly used. So to understand a distribution of data, so let's say you have xi, okay, for a data xi, I value is mostly ranging from your 1 to n can be anything. And these are the data 1 to n to be stored in increasing order, so that the first value xi data is the smallest observation, and the xn is supposed to be your largest of some ordinal and numeric attribute x. So for each observation that is xi, it is to be paired with a percentage fi. Individual, I mean every data should have a percentage associated. So in that case, what will happen? So it will indicate that approximately fi into 100% of data are below the value of xi. So this is a little bit complex type of plot. You can see more details in book. Next, moving over to quantile, quantile or QQ plot. Okay. So this type of graph, it has different quantiles of a certain type of distribution against the corresponding quantiles of others. So here you can, in this distribution, so on the basis of this middle line, you can say which one is the first quartile, which one is median, and which one is the third quartile. Then you have another type of plot called scatter plot. So scatter plot is the one of the most effective graphical methods of determining if there appears to be a relationship, pattern, or trend. between two numeric attributes. So here this figure shows the more number of items are sold at the unit price 80. Okay. Then positively and negatively correlated data. So how you can say that how the data are actually correlated or complementing each other by looking into their distribution. So let's say if there are two attributes x and y, and if they are correlated, then if one attribute implies the other, we say if one attribute will implies to other, that is x and y implies to each other, then we can say that they are correlated. So correlations can be again positive, negative, or null. Null can be also called as uncorrelated. So if the set of points plotted, okay, in that pattern, if it slopes from lower left to upper right like this, so this means that the value of x increases as the value of y increases, so suggesting a positive correlation. But if the pattern of plotted points slopes from upper left to lower right, then the values of x increase as the value of y decrease. Okay, so x is increasing, but the y value is decreasing. So in that case, it will suggest that it will show that it has a negative correlation. Okay, and a line of best fit can be drawn to study the correlation between the variables. Then see in this type of pattern, you can see that in all of the three cases, there is no actually any correlation or no correlation relationship between two attributes. Okay, you cannot say that anything is positively correlated or negatively correlated based on the xy axis values. Then next, coming to data visualization, it's mostly theory, different format of data, in what kind of data you have and what are different forms of it. And for understanding each type of data set, it's again it's again a complexity. There are many challenges to understand also. And data visualization actually aims to communicate data clearly and effectively through graphical representation. It can be used to it can be used in extensively in many applications. Let's say at work, if you are working, you may use it. The data visualization you can maybe you can use it for reporting, managing business operations, or tracking progress of tasks. Here, see, this is one type of visualization here. You can say that there are different set of, in a data set, there are different categorization through which you can understand. So let's say if a data set has a number of dimensions, so this is um, your one pattern based on one category, this is second pattern based on another category. Like that, you have the age category as well. So from this, the way you will set your visualization, from there you can understand that how the data actually behaving, or what is the characteristics of the data actually. So here you can see that transaction volume, or let's say the credit limit. So here the minimum value on the bottom, here the credit limit is high, or here at most 30% or 25% of the income is high here in the below end. So this is depends on um, how the distribution or picture or image actually looks like based on your setting of data. Like that, there are different set of data distributions. You can go through one by one. So in this format also it can be represented circle segments. There can be geometric progressions like this. You can zoom in, zoom out the data to understand. You can also rotate it. Then comes your scatter plot. This is mostly used, always used. So if the data is scattered in this way, a scatter plot, so you can divide it. Let's say there are three flower species, Setosa, versicolor, virginica. You can divide them in this way, multiple pictures, and then from their patterns you can understand what are their characteristics. This is how the scatter plot actually looks. Landscapes, some of the visualizations. Okay. Okay. So the data visualization, you can refer the book to get into more details about visualizing those data, and you will have an idea what type of data you may encounter. Then measuring data similarity and dissimilarity. This is the most important concept. So in some of the tests or assignments that I will be giving you, um, so this is the most probable question you may have: similarity, dissimilarity. So there can be a cluster which may be a collection of data objects, so such that the objects within a cluster are similar to one another. So let's say you have a collection of data. So how can you determine, are they similar to each other or are they dissimilar? Okay. So based on that, actually this concept is relying mostly. So looking into dissimilarity. So there is a dissimilarity measure which works in the opposite way of similarity measure. So similarity measure means how similar, dissimilarity measure means how dissimilar are they. Uh, so if so if two objects have a dissimilarity measure of 0, then you can say that they are not dissimilar or they are totally same. Okay, and they are far from being dissimilar. So if you will have higher value of dissimilarity, then the two objects are mostly dissimilar. Then how can you present the dissimilarity matrix from a data matrix? So here see the first data matrix. Data matrix is called an object by attribute structure, and this structure actually stores the n data objects in the form of a relational table in this way, n by p matrix. Okay, and here n is the number of objects and p is the number of attributes of those objects, and here each row will correspond to an object. Okay, each object has p set of attributes, and the total size or shape is n cross p or n by p. So how can you arrange the dissimilarity from here? So dissimilarity matrix is also called object by object structure. Okay, as I told you, every row is corresponding to individual object. So here this dissimilarity matrix, it stores a collection of proximities that are available for all pairs of n objects, and it is often represented by n by n table. So if you see this first one, d of 2 1, we can say d of ij. Okay, so d of ij is the major dissimilarity or difference between objects ij. So for d21 we can say that what is the difference or the proximity or the distance measure between object 2 and 1. Okay, so let's now see one example. So before the example, I need to mention about the formulas. So if you remember, we have nominal attributes, right? So in the case of nominal attributes, how do you find the proximity measure? How do you find the distance? So nominal attribute, what is nominal attribute? Which can take two or more set of states, correct? So let's say you have a nominal attribute as map color. So the map color, it can have different values like red, yellow, blue, green, like this. Okay, and here let's just consider let the number of states of nominal attribute, these are number of states, so let's the number of states are m. Okay, and the states can be denoted by letters, symbols, or set of integers, right? So if you see in the first method, how to find the dissimilarity? Okay, simple matching. So if m is the number of matches, that is the number of attribute for which I, j are same, okay, are in same state, and p is the total number of variables describing for the objects. Then the proximity measure dij will be computed in this way: total number of variables minus how many number of matches divided by total number of variables. Okay, we are going to use this formula in one of the example. Here, see this problem. Again, you will find the same example from book as well. Okay, so we are going to find out the dissimilarity between the nominal attribute. We are going to compare between each nominal attribute with other one. If you see, here you have three attributes: test 1 nominal, test 2 ordinal, test 3 numeric. We are considering just test 1 nominal and object identifier. There are actually 4 objects, total 4 objects, and total 4 attributes. So based on this formula, what is P here? P is total number of variables or objects, that is your 4, 1, 2, 3, 4. So how can you find out M now? M is number of matches. So let's see that. Let me annotate here. Suppose say you want to find out, here see, you need to basically find out this one, this matrix. So the diagonal elements will be 0, okay, always. Here you will start with the, actually why they are 0? For the first object, so in between the same object, the similarity is more, so the dissimilarity measure will be 0. Like that, second object, just compare the ij, the row and column. So within the same, if you are considering the same object, same variable, then the dissimilarity will be 0 because they are same. Because of that, you have the diagonal values as 0. Now let's see how to find out d of 2, 1. Okay, what is the basic formula? So d of 2, 1, how do you find out? The comparison between your 1. 1 is what? Code A and your code B. Okay, so we will basically compare in between the code A and code B nominal attribute. And here what is the match? We have a formula of P minus M divided by P, correct, from the last slide. So first we need to find out the match. So for D2, 1, are they similar? They are not similar, they are different, right? Code A, code B are totally different. So the match will be what? If they are different, the match will be 0. If there will be a match, then you will have the match value as 1. So if match is 0, what is your P? Okay, what is your P? P is your total, how many number of objects you have here, okay, total number of variables, that is 4. So 4 minus 0 divided by 4, and here you will get 1. So do you have 1 here? This one, D21 is corresponding to 1. Do you have any question in it, or is it understood? Then likewise you can now consider D31. Okay, let's make it D31. So 31 will, what you will do? You will do a comparison in between 3 object, that is code C and code A. Are they equal? They are not equal, correct? Code A and C. So is there a match? There isn't a match. So M will be again 0. And again 4 minus 0 divided by 4. It will be 1. So D31. So you are having a 1 here as well. So like that you can calculate the dissimilarity or the proximity or distance in between all the different nominal attributes in this way. Give me a moment. It's hang now. Now, next, that was nominal. Next, move over to binary attributes. Okay. So, binary attribute is what? It can have only two sets only. So, two states, that is 0 and 1. So, 0 means when the attribute is absent. 1 means when it is present. You can refer to the binary attribute slide. So, let's say you will say that you will be given an attribute smoker describing a patient. So, here if you have a value as 1, that means what? The patient smokes, while the 0 will refer that the patient doesn't smoke. Now, how can we compute the dissimilarity between two binary attributes? So, there is a formula you need to remember. So, first, in the contingency table of binary data, how is it being organized? This is really helpful to apply them in the formulas later. Okay, so just be careful and look at this table. Here, you have an object I, object A. You just are basically going to find out the proximity measure. Okay, but before the proximity measure or distance, we are going to see the how they are organized. So object I can have 1 and 0 state. Object J can have 1 and 0 state. There is another one column here, sum, and here also there is another one column, sum. So Q is what? Q is the number of attributes that is equal to 1 for both the objects, 1, 1. R is the number of attributes that is equal to 1 for object I, 0 for object J. S is the number of attribute that's equal to 0 for object I, but 1 for object J. T is the number of attributes that equal to 0 for both object I and J as well. And the total number of attribute is P here, which is equal to Q plus R plus S plus T, all of them together. Now, if you remember, binary data is again of two types, symmetric, asymmetric, correct? So let's say if you have a symmetric binary variable, in that case, what will happen? So each state are equivalent or of same weightage, equally valuable. So dissimilarity will be best, which is based on symmetric binary attribute, is called symmetric binary dissimilarity. And this is the formula in which through which you calculate the distance measure of symmetric binary variable. But let's say if you want to calculate the distance measure for asymmetric where the states are not equally valuable, so this is the formula for that. There is another one, Jacquard coefficient. Okay, and for that coefficient you use this type of formula. Okay, it's, the Jacquard coefficient is also similar to coherence. The coherence is formulated in the last formula as shown. Let's just emphasize for now. I'm going to show you one example which is mostly based on the proximity measure or distance measure of asymmetric binary variable. Let's see this example. Okay, so see here. In this table, there are three objects, Jack, Mary, Jim, and these are the attributes. If you see the attributes, can you consider the gender as symmetric? Correct. Yes, right. Both of them are equally weighted. All of them, that is F and M. So just for the time being, make it aside, keep it aside, and consider other attributes which are not symmetric. They're asymmetric. Now, for asymmetric attribute, this is the formula R plus S divided by Q plus R plus S. We are going to apply that formula here. Okay. Just one moment. So just to simplify, I have taken another one slide here. First, we want to find out the proximity measure in between Jack and Mary. So if you refer to previous slide, the formula is what? The formula is your r plus s divided by q plus r plus s. Okay, so now let's just find out what are the values of q plus r plus s. Sorry, the r, s and q values. So what is r here first? We are just going for the first one, Jack and Mary. Okay. So R is the number of attributes that is equal to 1 for object I, that is Jack, but 0 for other object J, that is Mary. Okay. So for Jack, we want Jack should be 1 and Mary should be 0. Jack, Mary. So 1, 0, how many times do you have it here? Do you see any 1, 0 combinations in between this? No, right? So there isn't any. So for R value, you will just put 0. Then S is what? S is the number of attributes. It is equal to 0 for object Jack. Jack should be 0, but equal to 1 for the object J, that is Mary. So Jack is 0, Mary is 1. How many times do you have here? Only once, right? So 1 divided by Q. What is Q? Q is the number of attributes that is equal to 1 for both of the objects, Jack and Mary. So how many times do you have? 1, 2, 2 times. Again, what was our R? 0. What is S? S is 1. Okay. So total, you will have this much. So like that, can you find for Jack, Jim and Jim, Mary? You just have to go through the RSQ, all these values, then you will be able to find out the proximity measure. Any question in this? Okay, next, moving over to distance on numeric data. That was distance on binary data. Now, if you have numeric data. So, what happens now? There are different types of distances, very famous distances. Minkowski, Euclidean, then what else you have? Manhattan distance. So what are the cases? So actually the Minkowski distance is the origin, which is a generalization of Euclidean and Manhattan distances. Here if you see the formula, so age is actually is a real number and it is always greater than or equal to 1. So such type of distance is also called LH norm in some literature where the LP norm where the symbol P refers to our notation of H. It depends upon what value of H you are choosing. So based on that you determine which one is Minkowski, which one is Euclidean and which one is Manhattan. Okay. So we have to keep the P as a number of attributes to be consistent. And here, if you have uh, the H value as 1, okay, that is called L1 norm, okay, L1 norm, and that type of distance is called as your Manhattan distance. And if you have H value as 2, then that is called L2 norm and it is called Euclidean. We will go into that. We will see the pictures. These are the two types, just to remove confusion. I'm mentioning that. Then these are some of the properties, how the distance measure will vary. So if distance between two objects ij is greater than 0, that means there is some distance. So they are not similar, that is I not equal to j. And the distance measure, if it is 0, you are distance between the same object I and I is 0, that means there is a positive definiteness that they are similar. So for similarity condition, there is another one, triangle inequality condition as well, some of the properties. Let's move over to the Euclidean distance formula. Okay. So here Euclidean distance is shown in this format. They kind of look similar. So if you are having the h value, that is this h value as 2, then it becomes Euclidean. If it's 1, L1 norm, then it is Manhattan. Let me show you all of them together. So if first basic, you have Minkowski. It's the origin of, or generalized, it's the origin of all distance, or it is also called a generalized distance. But if you have that h value equal to 1, that becomes your Manhattan distance, and this is the formula. Okay. Then if there is h value is 2, this is your L2 norm, and it becomes the, you can see the power of 2 here. Okay, the values are normalized and there is a 2 power. Then if the h value will become infinity, that type of distance becomes supremum distance. This is the formula for that. We will see first the Euclidean, which is mostly used distance in analysis. So what is Euclidean distance? You can refer this formula here or this one, but how it works. So if let's see here, if you remember in the last slides, we have seen the diagonal values will be always 0. And why? Because distance between x, here see there are 4 points or 4 objects, x1, x2, x3, x4. For attribute and attribute 2, each of the objects have their own set of values. Correct? Now we don't have, let's say we don't have the Euclidean distance or dissimilarity matrix. Using the formula, you are going to determine that. So distance between x1, x1 is what? They are same, 0. x2, x2, 0. x3, x3, 0. x4, x4, 0. Diagonal, you have always 1. Always 0. You don't have to compute anything. Now first, let's find out. I'm going to annotate here. First, we are going to find out the distance between, oh sorry, this one, d of 2, 1. You can just compare d, distance of object 2 and 1. Okay. So this is your object x2 and x1. How do you calculate it? That will be, what is the attribute 1 value for object 2? That is 3. What is the attribute 1 value of object 1? That is 1. You just have to subtract them. Here it is Euclidean distance, so you will use h equal to 2 or the power 2. Add with what? Now the difference between attribute 2. That is 5 and 2. So 5 minus 2 of square. Then you need a square root. Okay. So when you calculate that, you will have the value as 3.61. Like that, can someone tell me how do you find the distance between x3 and x1, 3 and 1? Anyone want to answer? You can type on the chat box also. Okay. No answers? So in between 3 and 1, how do you find out? So 2 and 1. So attribute 1 value, difference of that. 2 minus 1 and x1, x3, x1, that is 0 minus 2. Okay. So d of 3, 1, you will get this much, 5.1. Like that, if you want to find out the x3, x2, then what will you do? You will consider x3, x2. So 2 minus 3 square plus 0 minus 5 square of square root. That will be your Euclidean distance between x3 and x2. Any question on it? Can you calculate the x4, x1, x4, x2, x4, x3? Yes, the order matters. Yes. You can refer the example and try to calculate on your own also. Now, like you saw the Euclidean distance for h equal to 2 or L2 norm, like that, using the previous formulas, you also can find out Manhattan for power of 1 and supremum for power h of h is as your infinity. Like that, you can find out both all of the three. Euclidean already I have shown it here. This is the same thing that you have. It's repeated. Next concept, cosine similarity. Okay. So cosine similarity is a measure of similarity that can be used to compare different types of documents. Okay. So let's say you want to give a ranking of documents with respect to a given vector of query words. Okay. So let's say we have set of documents, 4 set of documents here, and um, each document can be represented by number of attributes. So here how many attributes you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are 4 objects or 4 documents. Okay. So you want to find out a cosine similarity in between the some pair of documents. So how would you find that? So here, see the applications, some sort of information retrieval, a biological taxonomy, gene feature mapping. So in that application, on those applications, you may find this cosine similarity concept useful. Let's say there are two vectors d1, d2. We have two vectors, and their cosine similarity. How you can find out? This is the formula for that. Dot product of d1, d2 divided by norm of norm value of d1 and norm value of d2. So to understand that, let's so here d is actually the length of vector d. So and dot indicates the dot product. See this example here. This is the formula. If you remember d1, d2. So d1, we are taking this d1 document and d2 document, and we are going to find out the cosine similarity in between those two. So first, write down the object name, document name, and their attributes. So first, as per the formula, you want to find out the d1 and d2 dot product. Okay. So dot product, how to find out? 5 into 3 plus 0 into 0, 3 into 2 plus 0 into 0. Like this, you will go on, and this is how you will find out the dot product of two vectors, that is two documents. Then there is the formula divided by norm of d1, norm of d2. So how do you find out that? In that case, just consider the formula is just consider the first one, this one. Okay. Only the only this one. And to find out the norm, you just consider 5 into 5 plus the second one, 0 into 0. Each number will be multiplied with itself and they will be added together. Then you basically find out the square root of it or make a power of 0.5, and that is your norm value of d1. Like that, find out d2, then just divide them and find out the value. Okay. So this is pretty simple. You just have to follow the formula and you can easily get cosine similarity. Now like that, like the binary, nominal, you can also find the ordinal variables proximity measure. So you can refer the formula and the example here to find out them. Okay. This is the again some of the formulas for mixed type as well. Okay. So this is the end of our second chapter, data. To this point, do you have any questions?
Is there anything due soon?
No, nothing is due now. I'll post announcement. I'll also declare in class as well. You just read both of the chapters. I'm just waiting for another chapter, important concept to be covered. Then probably I will give a test. Okay.
Everything that we've covered in these slides, are those also in the chapters in the book, chapters 1 and 2?
Yes, yes. Any question?